What are the health hazards of space travel? Radiation and the lack of gravity cause a wide range of health problems. The most dangerous health problems include loss of bone density and muscle mass, damage to the heart and immune system, the breakdown of DNA, genes, and cells, and an increased chance of cancer due to radiation. The loss of bone mass in space is basically aging, only at a faster rate. After a normal person reaches peak bone mass, they start to lose bone mass at a rate of 1 to 2% a year. An astronaut in space loses bone mass at a rate of 1 to 2% per month. That is because without the stress of gravity on bones, the impulses that tell the bones to produce more cells stop. So not only does it continue to decrease, but no new cells are being produced. Over a long space flight, such as to Mars, up to 20 to 30% of bone mass can be lost. This dramatic loss can be somewhat regained when the astronaut returns to Earth, but it creates more skeletal problems as the astronaut ages. A similar depletion process happens to muscle mass in space due to lack of use. Therefore, the amount of muscle created is decreased, while the muscle loss continues, and overall muscle mass is lost instead of replaced. This can produce atrophy, which causes weakness and fatigue. Both of these hazards interfere with the notion of space travel and exploration because there's no purpose in sending people to Mars if they cannot function when they get there. The heart is also adversely affected by zero gravity in space. Not only is blood pressure changed, but it is also harder to pump blood to the extremities, so most of it remains in the chest cavity. This means that the body thinks it has excess blood, so it produces less. This results in the weakening of the cardiac muscle since it has less blood to move around. This slow atrophy of the heart produces effects like that of premature aging. The immune system works with much less efficiency in space. A certain signal pathway does not work correctly in zero gravity. This causes T cells, which are specialized white blood cells, to fail to fight infections. Also, latent diseases can be reactivated with the weakening of the immune system, and diseases that would normally be easy to fight off are not. In addition, diseases that wouldn't even be contracted by a healthy person are now a hazard. This means that astronauts are sick much more than we on Earth are. Because they are no longer blocked by our planet, astronauts in space face the risks that come with exposure to high radiation levels. They face an increased chance of 1 to 19% of contracting life-threatening cancer. Faraway supernovas throw galactic cosmic rays, or GCRs, out at near light speed that contain heavily ionized nuclei. Without the protection of Earth, these will pass through astronauts and damage DNA and genes and kill cells. So as we can see, research is necessary, not only to know the effects of these hazards, but also to protect astronauts from them. The danger to our bones, muscles, heart, immune system, and from radiation are too great to ignore. If humans want to continue to reach out and explore further regions of space, these perils must be investigated, and solutions must be found to combat these health hazards of space travel.